Welcome back to Physics for All YouTube channel. In today's session, I am going to explain you about classification of semiconductors into two types. They are known as intrinsic semiconductor and extrinsic semiconductor. Now, we will discuss about intrinsic semiconductor in detail. So, what is intrinsic semiconductor? A pure semiconductor crystal is known as intrinsic semiconductor. That means inside of that intrinsic semiconductor, no other element is present. That is completely all atoms belongs to one category. That is the meaning of intrinsic or pure semiconductor. To know about intrinsic semiconductor, let us consider one example of semiconductor. So very best example for the semiconductors are silicon and germanium. If you can observe the atomic number of silicon atomic number is 14. Now write its electron configuration of silicon. I can written as 1s2, 2s2, 2p6, 3s2 and 3p2. If you can observe the valence electrons of silicon, it contains 4 valence electrons. Similarly, you can write germanium atomic number. If you can write the electron configuration of germanium, it also contains 4 valency. So 4 valence electrons means what we can call it as? It is called as tetravalent. It is called as tetravalent. What is the meaning of tetravalent? Tetra means 4, valent means valency. That means silicon and germanium are having tetravalency electron. Now the conductivity of intrinsic silicon, intrinsic germanium can be divided into two cases. That is equal to, first I am going to discuss about conductivity of semiconductor, that is equal to absolute temperature, that is 0 Kelvin. At this temperature, now here the each and every silicon is bonded with the other silicon atom as shown in this diagram. Now I am going to consider one silicon. Okay, for this silicon, this is a first electron of the silicon, it is a second electron, and it is a third electron, it is a fourth electron. So 4 means what? Silicon is having tetravalency. That means each and every silicon has a 4 valence electron. You can consider another silicon. Here also this is the first electron, it is a second electron, it is a third electron, and here is a 4 electron like this. You can take any silicon atom along the x dimension, y dimension and z dimension. Each and every silicon is having 4 valency. Therefore, it is called as tetravalent atom. Now, what happened here? The first electron of the silicon is bonded covalently with the other electron of the upper silicon. Therefore, this first electron of the silicon bonded covalently with the upper electron of the silicon. So, one covalent bond is completed. Similarly, the second electron of the same silicon bonded covalently with the other electron of other silicon. So, 2 covalent bonds is completed. Similarly, the third electron of the same silicon bonded covalently with the other electron of the below silicon. 3 covalent bonds, and finally the fourth electron of the silicon bonded covalently with the other electron of the left side silicon. So what we can say, for each and every silicon atom, how many bonds are going to become? 4 covalent bonds are going to become completed. So in each and every bond, 2 electrons are there. So we can observe 4 electrons. 4 is into 2, that is equal to 8 electrons are associated for each and every silicon. These 8 electrons are occupied in the valence energy level, that is equal to first silicon, first electron, second, third, 4, 5, 6, 7, like this. Each and every silicon is having 8 number of valence electron. These electrons are available in the one level inside of the valence energy band. Now coming to this here, at this temperature, no electron is free. At this temperature, no electron is free. That means no electron is free to carry the charge from one place to the other place at absolute or 0 Kelvin. At this temperature, because of no electron is free at 0 Kelvin, this material can show high resistance and almost you can say 0 or low conductance. Therefore, at absolute temperature, this intrinsic semiconductor behaves like perfect insulator. This is about the intrinsic semiconductor conductivity at T is equal to 0 Kelvin. At this temperature, the conduction band is equal to completely empty. Now I am going to discuss about this semiconductor in detail. Let us listen carefully without skip the video, completely understand. If you people are having any doubt, you ask me in the form of comment. I will explain you in detail. In one more time, I will explain you. But this is very important topic. If you can understand this topic, the total unit is completely going to become understand. Okay. Now these semiconductors are having an important property that is called as negative temperature coefficient. This is a property of semiconductor that is called as negative temperature coefficient of resistance. This is a property of semiconductor. According to this property, if you can apply temperature to this semiconductor above absolute temperature, that means what happened? I am increasing the temperature. Now I am going to increase the temperature of semiconductor. Increase the temperature of semiconductor. That means now what is the temperature? 0 Kelvin. Now I am going to increase 1 Kelvin, 10 Kelvin, 20 Kelvin, like this. I am increasing the temperature gradually. If temperature increases gradually at a particular temperature, what happened? There exists a covalent bond. Now between the one silicon and other silicon, covalent bond is going to form. Okay. Now when temperature is going to become increasing gradually at a particular temperature, what happened here? The applied temperature is more than the bond energy. At this condition, between the one silicon and other silicon, covalent bond is going to become break. Okay. So whenever covalent bond becomes a breakdown, inside of that covalent bond, one electron becomes free. Now this electron is called as a free electron. This electron is called as a free electron. Whenever this electron is moving out of the bond, then what happens? Wherever electron is there, that place becomes empty. This place becomes empty. Okay. Whenever this place becomes empty, this empty space of the electron where previously it is located, that space is known as a positively charged. That space is known as a positively charged, which is called as a hole. Now listen carefully. Whenever temperature is going to become increased gradually at a particular temperature, the applied thermal energy is more than the bond energy. Immediately bond between the one silicon and other silicon is going to become breakdown. Whenever a bond becomes breakdown, it causes removal of one electron from its bond. This electron is called as a free electron. Now this electron is moving randomly inside the valence energy level. Now whenever electron becomes free from its bond, wherever the electron becomes empty, that empty space is called as a hole. This hole has a positive charge. Okay. Now if you observe at the temperature more than absolute temperature, now we are going to observe formation of free electron as well as creation of hole. Okay. Now in this situation, the electrons and holes are formed here. Electrons and holes are formed here. Now you can apply some energy in the form of voltage, and then in the case of temperature, the electron which is moving freely in the valence level now moving to the conduction level. Whenever conduction band reaches the electron, these electrons are called as conduction electron, and holes are remaining in the valence level. Whenever conduction band reaches the electrons, what we can say, conductivity is going to increase. Whenever conductivity goes to increase, for this material at the temperature, resistance is going to become decrease and conductance is going to increase. So now we will increase the conductivity as the temperature is going to increase. At this condition, this material has a high resistance and high conductance and low resistance. This is about the conductivity of intrinsic semiconductor at T is equal to 0 Kelvin and T greater than 0 Kelvin. The conclusion is here is at T is equal to absolute temperature, the semiconductor behaves like insulator and temperature is going to increase above zero temperature. The same semiconductor now converted into conductor and exhibit conducting nature. Therefore, the properties of semiconductor switched between insulating property to conducting property. Therefore, this is known as semiconductor. Now, this is completely conductivity of intrinsic semiconductor under two conditions, T is equal to 0K and T greater than 0K. This is about this topic. In the upcoming topic, I am going to explain you about extrinsic semiconductor. Now, to increase the conductivity of extrinsic semiconductor, there are two methods we can apply. There are two methods we can apply. The first method is temperature increases. If we can increase the temperature of the semiconductor, what we can observe? Its conductivity. Its conductivity is going to increase. Okay, this is one method. Other method is the conductivity of the semiconductor can be increased by doing doping process. What is the meaning of doping? Doping means addition of. What is the meaning of doping? Addition of impurity atom. Addition of impurity atoms or impure atoms into the pure semiconductor. Whenever this impurity are added into the pure semiconductor, it can also increases the conductivity. Now, depending on the doping method, we are going to classify semiconductors into two categories. Number one is called as extrinsic semiconductor. What do you mean extrinsic semiconductor? An impure semiconductor. An impure semiconductor. An impure semiconductor is known as extrinsic semiconductor. Depending on the type of impurity, adding into the pure semiconductor, these extrinsic semiconductors are classified into two categories. Number one is known as N-type semiconductor. Number one is N-type semiconductors, and number two, listen carefully, P-type semiconductor. Now I am going to explain you about the formation of N-type semiconductor and conductivity of N-type semiconductor, as well as P-type also we can discuss in detail. Without skipping, watch this presentation completely. This topic, which is N-type and P-type, completely important for the examination point of view. If you can understand this topic, total chapter will be understand. This is introduction of extrinsic semiconductor. Now, in the upcoming session, I am going to explain you about N-type semiconductor and P-type semiconductor. Watch this presentation completely without skipping. If I have liked this presentation, share this information